Chapter 12, Lesson 6, Permutations and Combinations, and we are going on the fifth try. The fifth try, hope it is the charm here today. So permutations and combinations, very similar, very obnoxious to calculate, especially when your numbers are large, but this is the gist of it. A permutation is when you have a number of items and every different way you arrange the item is a different outcome. The example they give you is if you have 4 bats, A, B, C, D, and you are arranging them in order in which the arrangement makes it a completely different order, like in baseball or softball. If you have a different batter's order, you can't just bat 9 people in any order they want. You have a very specific order. It makes a difference. So A, B, C, D is different than A, D, C, B, and D, B, C, A, and so on. So in order to do that, we actually call it the fundamental counting principle. If you're choosing 4 items and using all 4 items, you just multiply, start with 4, and multiply all the counting numbers down to 1. So 4 times 3 times 2 times 1, which is 24. And it's also written as 4 factorial. So if you've been watching in Alex, some of you have already gotten to that, and really you saw it last year in the 8th grade curriculum. So that is the same thing. Algebraically, this is how we write it algebraically. If you didn't know what the number was, you call it n. And so the first number would be n, and then it would be 1 less than that, so n minus 1, and then 2 less than that, so n minus 2. So that's kind of ugly. It's a little easier to think about when you're actually dealing with numbers. Okay, so in that first example, 7 friends are sitting on chairs and they're getting ready to watch a movie. How many ways can they be arranged? I'm going to underline the word arranged because that is very, very important in this case, because arrangement matters. If they are arranged differently, it is a different outcome. And so we have 7 kids. They're all 7 being used. So 7 times 6 times 5 times 4 times 3 times 2 times 1, and that answer should be 5,040 ways. We will have some pretty big numbers today, so don't be surprised by that. There will be some big ones, okay? So very similar to the fundamental counting principle is a permutation where maybe you are have 5 players or 5 things to choose from, but you're only choosing 3 at a time. So take a look at this one. Suppose Angie's coach had 5 players in mind for the first spots in the lineup. How many different batting orders could she make? Okay, so notice there's only 3 spots. There are 5 people to choose from, so she starts with 5 and then the 4 and then the 3, but then we're done because we're not going all the way down to 2 and then 1. All right, so it's just the first, starting at 5, and we count down 3 spots. So this is where you start and this is where you count down. Now mathematically, this is the formula for that, and they show you. So n factorial, which would be 5, 4, 3, 2, 1, and then we divide by n minus r, number that you have minus the number that you're choosing. Well, 5 minus 3 would be 2, so 2 times 1. And if you look, those 2 always cancel out, so you end up just using the first however many you are taking. So I don't honestly use this formula all that much because it's easier just to count down how many I'm taking. And let's do that, a couple practices with that. We'll turn your paper over, and we've got 2 examples of permutations, all right? Helmets. In a cycling store, they have 8 new helmets, and they want to know how many ways 5 of them can be arranged or displayed in the window. So we have 8 to choose from, but we're only choosing 5. So we got 8 times 7 times 6 times 5 times 4. And I'm going to stop right there because that's 1, 2, 3, 4, 5 helmets. That's all I'm using, all right? And so when I do that, my answer is 6,720 arrangements. Notice you would if you did 8 factorial and then 8 minus 5 factorial divided by 5 factorial. Oops. Nope, just kidding. That would be the same thing. So it would be 8 factorial over 3 factorial. So it would be 8, 7, 6, 5, 4, 3, 2, 1. But then when we divide by 3, 2, 1, those cancel those. and you end up with the same thing. So I don't feel the need to write all this down because it's not necessary. All right, take a look at the second one, codes. Shay has a 4-digit passcode to access his email account. And the code is made up of the even digits 2, 4, 6, and 8. And each digit can only be used once. How many different passcodes could Shay have? Now, this is interesting. This is a permutation, but we're taking, and this is how they'd write it. It's a permutation taking 4 at a time. In other words, it's 4, 3, 2, 1. And the answer is just 24 codes, right? Okay, now that's permutation. That is when an order makes a different outcome. Now, what happens when that doesn't matter? Then we call it a combination, which is funny because your lockers, we say locker combinations, but it's really a locker permutation because the order in which you put your 3 numbers in very much makes a difference. Okay, so if it's a true combination, then it doesn't change any way you combine the chosen items. So this, like this, Angie, Beth, Cora, Cora, Angie, Beth, Beth, Cora, Angie, all 3 of those are exactly the same group. It's the same combo. All right, so when we look at it like that, we have to divide by one more thing. Then we have to take our permutation, which would be this part, and we're also going to divide by how many ways we can arrange the given amount that we're choosing. So how many ways can we arrange those 3 people, which would be 3 times 2 times 1, and that's why it's r factorial. I'll show you what this means. I'm going to do it longhand, and then I'll show you how I do it shorthand. Okay, Erin is considering inviting 9 friends to a concert. She only has 5 extra tickets. How many different groups of 5 friends can she invite? So she has a combination of 9 friends choosing 5 at a time. So what that looks like is 9 factorial, and then 9 minus 5 factorial, and 5 factorial, which is 9, 4, and 5. Okay, well, if I do that, 9 times 5, 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all over 4, 3, 2, 1, and 5, 4, 3, 2, 1. Well, look at here. That cancels that, and they're gone. Now, I'm going to do a little canceling here. 4 times 2 gives me 8. So I'm going to cancel the 8 with the 4 and the 2. And then the 3, I can divide 9 by 3. And I get 3 times 7 times 6. Times 6, which is 126. Now, I wrote all that out, but really, I could do this. I could say, well, I'm taking 9 times 8 times 7 times 6 times 5. The first 5, because I'm only choosing 5 at a time, that's a 7, but I'm going to divide that by how many ways I can arrange 5 things. And I get those 2 to cancel, and then look at here, I'm exactly where I started. And I can take 4 times 2 is 8, and 3 is 3 times 7 times 6, 126. I don't care which way you do it. Either one works for me because either way will give you the correct answer. All right, let's do a couple more of these, shall we? On the next page. Students, so here we're going to talk about, they're going to give you both at the same time, a combination or a permutation. They're not going to tell you which one. So in order to get the answer right, you're going to have to be able to determine which one it is. Okay, so this is just identifying permutations or combinations, and I can't stress to you enough, if it can be the same group any way you arrange them, it is a combination. So think about the word. If it can be combined in any way and still be the same, that's a combination. If the arrangement makes it different, that is a permutation. So in this example, Shane only can take 3 books on his vacation. He has 7 books to choose from. That is a combination. It doesn't matter how I combine those 3 books. It's the same 3 books. So I'm just going to do a shorthand. Combination of 7, 3 at a time gives me 7, 6, 5 divided by how many ways I can arrange 3 items, and 3 times 2 is 6. So 7 times 5 is 35 combinations. Okay? Now down here, all they're asking you to do is determine if it's a combination or permutation for these first two. James is creating an online photo gallery for his vacation pictures. Doesn't matter. Does it talk about how they have to be arranged or anything? Or are they just putting them all in one big vacation album? That right there is a combination. James decides to list the photos in chronological order. Right here, permutation. Okay, now the second part here, we're going to identify and then solve. How many ways can the letters of Sunday be arranged? Arranged, right there it is. 1, 2, 3, 4, 5, 6. So 6, 5, 4, 3, 2, 1. And our answer is 720. Now take a look at this one. How many different 3-digit numbers can be formed using 9, 3, 4, 7, and 6? Assume no number can be used more than once. Notice how many can 3-digit numbers. So it matters if I take 934, that is different than 943. So I'm choosing from 1, 2, 3, 4, 5 numbers, 3 at a time, and it is a permutation because order matters. So 5 numbers, 5, 4, 3. 5 times 4 is 20. 20 times 3 is 60 numbers. Keep going. Letter C. How many different ways can you choose 3 numbers from the following list? Assume that no number. Now, how many different ways can you choose 3 numbers? They're not talking about creating a 3-digit number. This right here is a combination. It's a combination of 5 numbers taking 3 at a time. So 5, 4, 3 divided by 3, 2, 1. 3's cancel. 4 divided by 2, and it is 10 combinations. The last one, how many ways can the top 5 finishers be arranged in a 20-person cross-country race? Top 5 finishers. Well, remember, the order that they finish is a different outcome because that's a different way to finish the race. So it's going to be 20 times 19 times 18 times 17 times 16. And that is going to be a really big number. Let me get that. 20 times 19, 18, 17, 16. So 1,860,480 outcomes or results, or however you want to label that. That's a lot. All right, turn that paper over. A couple more examples on the back. Just going to go through. If you can fast forward if you want, it's fine. Okay, 5 of 16 students were randomly selected to clean up the art room after class. What's the probability that Tim, Jim, Dee, Shelley, and Michelle are selected? That right there, folks, is a combination. So in that combination, we have 16 students chosen 5 at a time. So we've got 16, 15, 14, 13, 12 divided by 5, 4, 3, 2, 1. Let's see, 5 times 3 is 15, 4 times 4 is 16, and make that 7. So I have 4 times 7 times 13 times 12, and I get 4,368. So that's how many ways I can choose Tim, Jim, Dee, Shelley, and Michelle. However, I have to divide that by, or when I'm finding the probability, there's only one combination of those that out of our 4,368. So the probability of picking that one is 1 out of 4,368. So that's our probability. I'm going to leave it as a fraction because that would be a hideous decimal. Okay, look at this last one. There are 10 contestants in the state quiz bowl. 7 of the contestants are female. How many different ways can first and second place be chosen? So how many different ways can first and second be chosen? So that's a combination of 10 people, 2 at a time, which would be 10 times 9 divided by 2 times 1, which just makes that a 5 here, and we have 45. So there's 45 possible outcomes. What's the probability that the first and second are both female? Okay, well, if there are 45 total outcomes, how many of those outcomes are female? And so what do we do there? We are going to say, okay, well, 7 times 6 divided by 2 times 1. Oh, excuse me, I apologize. I did this wrong. It is first and second place. That's a permutation, 10, 2 at a time. So it's just 10 times 9. It's 90. Now, how many ways can I arrange the females? That would be a permutation of 7, 2 at a time. So 7 times 6, which is 42, and the probability would be 42 out of 90, which I can reduce to 21 out of 45, which I can reduce, take it 3 out, to 7 over 15. And that's the answer right there, 7/15. Did I do that wrong? 7 over 15. All right. So there, your assignment is to do your purple worksheet. And if you have any questions, come see me.